So say I give you the system of equations. 2x minus y is equal to 3 as the first equation, and then we have minus 4x plus 2y is equal to negative 6. And I want you to solve using Cramer's rule. So we know that x is going to be dx over d, and y is going to be dy over d. And how we find d is using the coefficients in both x and y. So the first column is going to be 2 and negative 4. The second column is going to be negative 1 and 2. 2 times 2 is equal to 4 here, and then minus negative 4 times negative 1, which is just positive 4. So we get 4 minus 4, which is equal to 0. Now, notice that d, when solving for x and y, is the denominator. And in this case, the denominator is 0, which is usually a bad sign because we don't divide by 0. But in order to get more information about the system, we should solve dx and dy. So now dx, we replace the coefficients in x with the constants. So we get 3 and minus 6, and then we write down the y coefficients as our second column. So now, multiplying these together, 3 times 2 is 6, minus negative 6 times negative 1 is positive 6, so we get 6 minus 6, which is equal to 0. Finally, dy is where you replace the y coefficients with the constant terms. So the first column is still the coefficients in x, and then the second column is the constant terms on the right. So now multiplying this, 2 times negative 6 is negative 12, minus negative 4 times 3, that's also negative 12. And simplifying, this becomes negative 12, minus minus leads to plus. And these are negative 12 plus 12 is going to be 0, since they're additive inverses as well. So now all three of our 2 by 2 determinants ended up being 0. And actually, as it turns out, if d is equal to 0 and both dx and dy are 0 as well, then the system is called dependent. And recall, for a dependent system, there are an infinite number of solutions, so there's no one unique solution. And there are two ways of writing the set of solutions down. You can solve in the original equation. You can solve for y. So, for example, here, to solve for y, you want to subtract a 2x from each side. So we end up getting negative y is equal to 3 minus 2x. And then since we want y, we divide by negative 1. Which basically just changes the sign, right? So this becomes y is equal to 2x, positive 2x, minus 3. So one way we can write our solution is in terms of the ordered pair x, comma y. But y we want to write in terms of this x. So instead of y, we want to write 2x minus 3, since it's a dependent system. But we could also say, but we can also say, if we want to be a little bit more advanced about it, that the solution is, in mathematical terms, the ordered pair x comma y, such that, and that's what that line means, such that either one of the equations are satisfied. So such that, let's go back top, 2x minus y is equal to 3. Right? Since if we solve one equation, then we solve the other one since they're dependent. Or, if you like the other equation better, you can write it the set of all points x comma y such that the second equation is satisfied. So what's the second equation? Minus 4x plus 2y is equal to negative 6. So minus 4x plus 2y is equal to negative 6. So there's 3 possible ways to write down the solution set, but we know that in all cases it leads to there being an infinite number of solutions, which is the definition of being a dependent system.